I'm so excited that you're watching this video because this will really solidify the compound interest formula for you. So today we're going to be talking about deriving the compound interest formula. We're going to discover where it really comes from. So let's set the stage with a problem. So for Andre's half birthday, his grandma decides to set up a savings account for him. She decides to invest $150 to start. The bank offers her 5% interest compounded annually. So that means the bank will add 5% of whatever's in there each year. So let's see what that looks like in a table. All right, behind me is a table that I'm going to use to show you how Andre's savings account is going to change from year to year. So let's look at the first year. His grandma invests $150 at 5% compounded annually. So this column right here is the starting amount of money in a given year. And this column is going to be the amount plus the compound interest that the bank gives you. So we're going to have at least $150, and then we're going to get whatever the bank gives us in interest. So that's going to be 150 times 0.05. In other words, 5% of 150. I can now find a greatest common factor for these two numbers. I know I can just add them, but I want to show you how we're going to derive this formula. So I can take 150 out, and then I'll be left with 1 plus 0.05. In other words, 1.05. That's all of my money plus 5% interest on it. This is what I'm going to start year 2 with. So I'm going to bring this guy right down here. So I'm going to start year 2 with $150 plus 5% of $150. Now I'm going to figure out what I'm going to make in year 2. So I'll start out with $150 times 1.05 plus 5% on that. So that's 150 times 1.05 like we had before times 5% of that, so times 0.05. This we can also factor again, and now we're going to have 150 times 1.05, that's what I'm going to take out, and I'm going to be left with 1.05. Well, you know that 1.05 times 1.05 is just 1.05 squared. So this is going to be 150 times 1.05 squared. This is going to be the starting amount for the third year. Do you see where this is going? So I'm going to have 150 times 1.05 squared. Now I'm going to do the same thing that I did up here, right here. And you can kind of guess, maybe, what you're going to end year 3 with. So I'll have 150 times 1.05 squared. That's my original amount. Plus 5% of that. So I'll have 150 times 1.05 squared times 0.05. And this we can factor again. We're going to get 150 times 1.05 squared times whatever's left, 1.05. And this is going to be 150 times 1.05 cubed. So 150 times 1.05 to the third power. This is what I'm going to end year 3 with. Do you see a pattern here? I end year 3 with whatever my interest was plus 1 to the third for the third year. I had it to the second for the second year. And notice that whatever I'm multiplying by, I'm multiplying my original amount. We originally invested $150. So let's figure out what the nth year is going to have. Well, if we look here, we started off with this guy to the year minus 1 power. So we can guess that we'll have 150 times 1.05 to this year minus 1, n minus 1. Let's imagine that we write it all out for this. So we'll have 150 times 1.05 to the n minus 1 plus 5% of that. Well, we end up adding 1 to our exponent in the end. So what we're going to end up with here is 150 times 1.05 to the n. So that's our amount if we have interest compounded annually, in other words, 1 time per year, for n years. All right, let's go a little bit deeper because sometimes we don't compound just annually. Let's see what it looks like when we compound quarterly or monthly. So now let's say the bank offered Andre's grandma the opportunity to have 5% interest compounded quarterly, so compounded 4 times per year. What's this going to do to our formula? How's it going to change it? Well, previously we had 150 times 1.05 to the t, or to the n, or however many years we had passed. And this, in other words, we can separate this inner part here to be 150, 100% of 150, plus 5% of 150 every year. So that's 150 times 1 plus 0.05 to the t. Our new one is going to change slightly. We're going to invest the same amount of money, so 150. We're still going to keep 100% of that money, so 1. But instead of just 5% all at once, we're going to do it 4 times per year. So let's break it up into 4 pieces. In other words, 5% divided by 4. So that's 0.05 divided by 4. Well, now we need to show that we need to compound this 4 times per year. We can't just divide this by 4. It's just going to bring our interest rate down. So we need to multiply however many years we have by however many times we compound. So that's going to be 4 times t, however many years. Now, we can kind of generalize this. This is going to give us some amount of money that we have, some amount of money that we invested, plus the interest that we earned. So we're going to make, we'll call it A, however much money we'll make. A equals the original amount of money we invested, we'll call that the principal, or P, times 1 plus our rate, in other words, our percent of interest, R, over however many times we compound per year, N. This is all going to be to the power of however many times we compound per year. So that's N times T. And this is our interest formula. And that's where it comes from. Pretty cool, huh? There's a lot of work that goes into developing these formulas, but now it actually makes sense. Thank you for watching this. I really appreciate it. See you soon.